Hey guys, welcome to Unit 3. Guess what? You all beat the odds. And you know why I say that? I'm not just being mean. I'm not being mean, although sometimes I am. You beat the odds because, frankly, Mr. Brust was teaching Unit 2, and you guys passed all those mastery checks. I don't know how you did it. Anyways, what we're going to do in this unit is we're going to learn how to solve one-step equations. And to do that, we're going to use our properties of equality. And if you look, we have on your notes, there's 1, 2, 3, 4. Properties of equality. The first one's the addition property, and that basically says that you can take any equation and you can add the same thing to both sides of the equation. Subtraction property, you can subtract the same thing from both sides of the equation. It's the same for multiplication and it's the same for division. Okay, so what does that mean? If you have an equation, I'm just going to make this up. Don't write this down. Don't write this down. But I'm just going to make up an equation like x plus 2 equals 10. Don't write that down. But look, here's the equal sign, and that basically tells you that whatever's on the left, this whole side over here, is the same as the whole side on the right. Now, at this point, I know you've solved the equations. I'm not going to go through everything like baby steps for you because I know that you've done this in Math 8 and so on and so forth. But what these properties say, what I'm getting at here, is that you can do the same thing to both sides of the equation. And what we're going to do to help solve the equation is we're always going to do the opposite. Because if you have some unknown number and you add, say, 2 to it, what is the opposite of adding 2? You can work backwards and find out what that number was. The opposite of adding 2 is subtracting 2. Okay, so that brings me to the next slide here, which is all the inverse operations. How do you undo addition? You use subtraction, and that's called the inverse operation. Inverse means work backwards, okay, the opposite in mathematics. So the opposite of addition is subtraction. The opposite of subtraction is addition. So on and so forth. We have multiplication and division, division and multiplication. So we're going to use these inverse operations to solve our equations. We're going to start with a very simple equation. X plus 3 equals 12. And Mr. Brust likes it when you draw that line right here. So we're going to do that when we solve the equations to help us, it kind of recognizes which side is which. And when the equations get more complicated, then this line down the equal sign is really going to help us. So to solve these, first step, draw a line down the equal sign. Okay, and then you kind of say this to yourself, x plus 3 equals 12. There was some unknown number, and you added 3 to it, and it equaled 12. You have to go back and use the, where are we? It was plus 3, so that's addition. The opposite of that, the inverse operation, is subtraction. So that tells you what you have to do, and the line that we drew shows you where each side of the equation is. So you have to do minus 3 on this side. You also have to do a minus 3 on the other side of the equation. Okay, draw a big old line. Now, if you take a number and you add 3, but then you subtract 3, you're going to end up back at that number. So what we're saying is the adding 3 and the minus 3, they cancel. So draw a line through it, and you're left with the result underneath x. Okay, how about on the right? 12 minus 3. Well, that's equal to 9. All right, so what do we have here? We basically, I'm going to write it down here so it's nice and clean. We have x equals 9. That is the answer to the equation. Now, we need to check our answers. I mean, we're not going to go through this whole course and just blatantly throw answers down and be like, oh, this answer's right, this answer. You need to check the answers. To do that, I got us some good checking music. Let's listen to this.
If it means anything to you to know that I care for you, check it out. Oh, check it out.
All right, so that was some checking music. I got to be honest, that was ugly. That was bad, but I'm going to be singing that all day long. Here's how we check our answers. You're not required to do this. We're not going to make you do this on the homework. We're not going to make you do this on the mastery check. But you better figure this out right now. This class is based off of you learning and you getting it correct. So if you don't get it correct, you have no one to blame but yourself. You're going to have more mastery check. You're going to have more corrective assignments, more problems. So my recommendation is if you're unsure of the answer, you check it. Here's how you do that. You write the original equation down. So x plus 3 equals 12. You take your answer, we solved it and we said, we think x equals 9. So where the x is, you put a 9. 9 plus 3 equals 12. And then you actually figure that out. What's 9 plus 3? It's 12. So 12 does equal 12. Here's the check. Again, we're not going to make you do it, but if I were you and I had a mastery check and I had extra time, then I would do it. That's how we know our answer is correct. You can just throw it in the check there. All right, here's the next example. W divided by 3 equals 12. So this is a fraction bar, and in algebra, the fraction bar is division. It represents division. All right, so I'm going to go back here, division. The inverse operation is multiplication. So we need to multiply to solve this. You had some number W, you divided by 3, and it equaled 12. So we're going to undo the dividing by 3, and here's how we're going to show it. We're just going to put a little dot, that means multiply, on both sides of the equation. We're going to draw a line down the equal sign. And what happens if you take a number and you divide by 3, but then you multiply by 3? They cancel. So use your lines to show that they cancel. You're left with just W. And what's 12 times 3? That's 36. All right, I'm going to do one more check for you just so we can see how it works. We write the equation out. W over 3 equals 12. Wait, let's do some of that music first. Okay, I'll just keep going. That was kind of annoying. Plug the answer into the variable. So we have W divided by 3 equals 12. So here we're going to have 36 divided by 3 equals 12. And then you figure it out. Does that actually work? So 36 divided by 3, what is that? Use your fingers, use your toes, Mr. Sullivan. All right, there you go. 12 equals 12. So we know that check works. Okay, so again, here's our answer. That's what we're looking for on the mastery check. This is the check that you can do to make sure that you got it correct. Again, I recommend doing that. I wouldn't not do the check at all. All right, next example. 3 equals G minus 5.2. All right, there's two reasons I picked this problem. Number one, the variable's on the right-hand side, which doesn't make one splitting difference here. And the other reason I picked it is because we have a decimal. That also doesn't make a difference. You do the exact same thing you do if it was rewritten the other way. Now, if you want, you can write it like this. You can just put the G minus 5.2 on the left and the 3 on the right. But we're not going to do that. We're just going to use the opposite operation. You subtract here. Opposite of subtraction is addition. So that's what we're looking at right now. So we're going to add 5.2 to each side plus 5.2. They cancel out. We get 3 plus 5.2. That is 8.2 equal to. They canceled, and we have a G. So we get 8.2 equals G, which is the same as writing G equals 8.2. You know, either one of these are fine. You don't have to rewrite it, but you can if you want to, because I know some students like it better the other way. Hey, I'm going to show you a new movie. This is a trailer of a new movie that's coming out. I'm just going to give you about 10 seconds worth. That looks awesome, except that picture of Sully there. I don't really know what that's about. All right, so on to number 4 here. The reason I like number 4 is because it has that negative in front, and we see this all the time when we're solving equations. You're solving, you get down to negative x or negative p equals 23, and then how do you solve it? Well, that negative really represents a negative 1. It means the opposite of p, and one of the ways we can get the opposite of p is by doing negative 1 times p. And so, here's the rule. If you see a negative, just change it to a negative 1 right there. And now you can solve it. This is negative 1 times p. And so the opposite of multiplication is division. So that's what we're going to do to solve it. Uh-oh, where did my numbers go here? We're going to use division. We're going to divide by negative 1. And that's going to give us negative 23 equals p. And we're all done with that one. That is awesome. We're done. Now, you could also multiply by negative 1 on both sides. You're going to get the same answer there. Next question. Oh, man, one of these fractions. Now, students see fractions and they start crying and they're like the water and the tears and blah, blah. Look, just do the same thing. Look, this says x plus 2/3. Look, I'm reading it backwards. It's x plus 2/3 equals 2. So let's subtract 2/3 from both sides. And I'm just going to write it like that. And I know you all get those calculators, those graphing calculators. So I'm going to show you how to do this in a calculator right now. Here's the line down the middle. We have x plus 2/3. If we do minus 2/3, they will cancel, and we're left with x. And now we have to do 2 minus 2/3. Now your brain should be able to do that. I'm going to pull up the calculator here, but your brain should be able to do that very simple arithmetic. Okay, here we are with the calculator up, and we wanted to do 2 minus. Now, some of the calculators might be updated, some of them might not be. This one is not, and so here's how I put it in. Now, some of the new operating system can do the fractions right in there, but here's how you would do it without the fractions. You just go 2 minus 2/3. Always use parentheses when you have a fraction like 2/3, and you use the divided by sign for the fraction bar there. So when you hit enter, you get a number that looks like this. All right, so that's 1.33333, but if they're giving you answers in fractions, or they're giving you questions that have fractions in them, you should give them their answer with fractions. So I'm going to show you, if you go over here to the math button, math, and then number 1 says put my answer into a fraction, it'll take that 1.33333 and it'll write it for you as a fraction. And this says 4/3. So that is 2 minus 2/3 is 4/3. So let's go back here to our notes. 2 minus 2/3 equals 4/3. So you might ask, well, Mr. Kelly, if I don't have my calculator, how am I supposed to do it? You never show. All right, so I'll show you how to do it without a calculator. You have to go into thirds. So to go into thirds, you have to multiply. You got to get common denominators. So this is over 3. So let's see, that is over 1. So that's times 3. You got to do times 3 on the top. So it's 6/3 minus 2/3, and that's where your 4/3 comes from. So you don't need the calculator to do it, but it sure is handy. It sure is. All right, let's do number 6 now. Last one. Whew. And again, we're going to use the calculator to help us. This is negative 2/3 times x equals 1/3. Well, what's the opposite of negative 2/3 times x, or x times negative 2/3? The opposite would be divide by negative 2/3. Don't forget the negative. And I'm going to put parentheses around it. You're going to divide both sides by negative 2/3. This is about as ugly as it can get for you. So look, I'm going to put parentheses around this too, just so we can look at what's going on. You have x times negative 2/3. You want to divide by negative 2/3. Now, the way you do it by hand, it's 1/3 divided by negative 2/3. But you remember your rules for fractions. You have to flip it and multiply. So it's 1/3 times 3 over negative 2. Then the 3's would cancel, and you get negative 1/2. Okay, that's going to be our final answer here for x. I'm going to show you how to do it in the calculator, though, because you have this tool. You have to know how to use it properly. We want to do 1/3 divided by negative 2/3. So here we go. Parentheses, 1/3 divided by, parentheses, negative 2/3. Make sure you're using the negative button and not the subtraction button that's above the plus sign. You want to use the button below the 3. All right, you hit enter. You get that. Well, as I said, if they give it to you in fractions, you should give their answer in fractions. So you just change your answer into a fraction. You get negative 1/2. That's what we got before. Okay? So how are we going to show all this? Well, these cancel. We get x. Here's the line down the middle. And when we divide these out, we get negative 1/2, and we're all done with that. Hey, that's the first lesson. All right, application problem time. Let's do the application problem. We'll be all done. An American flag has an area equal to 9.5 square feet, while the length is equal to 1.9 feet. Find the width. Well, we know for a rectangle, the area equals length times width. All right, so we're going to set up. Let's mark our keywords here. So the area is equal to 9.5 square feet. The length is equal to 1.9 feet. And the question that they want us to solve, find the width. So we know that the width is not known, so that's going to stay a W. There's a little clue right there. The length is 1.9, and they give us the area is 9.5. Look, we have a little equation here. This is exactly what we're doing. We're learning how to solve these equations. We're going to divide each side by 1.9. We're going to get 5 feet is going to equal the width. Make sure that you put your units on there so that you communicate clearly what your answer is. All right, so that's the end of the very first section of Unit 3. Make sure you get lots of practice in. It's pretty easy. I think you've done it before, so take the mastery check. Good luck to you. Remember, it's nice to be important, but it's more important to be nice. See ya!
I believe this paradoxicality equation to be unsolvable. Ergo, time travel is impossible. But I can't quite prove it, Bubblegum. Perhaps you and your razzle-dazzle globetrotter calculus
Look
could...
pretty damn solvable to me, Fonzie. Sweet Clyde, use variation of parameters and expand the Ronskin.
Shiz, baby. So paradox-free time travel is possible after all.
Right on.